welcome to my YouTube channel. Today we are going to discuss unique paths 2, problem number 63 from that code. This is a more advanced version of previous problem, unique paths, which is problem number 62. It's also a very fine problem, which is, yeah, you can see from the likes and dislikes, okay? If you have not solved unique paths, I have already go to that problem, try to solve it by yourself. If you uh, um, get any error or any sort of trouble, I have provided the link in description. Let's check it. Okay, so let's read the problem statement. A robot is located at the top left corner of a M cross N grid. Mark the start in the diagram below. The robot can only move either down or right or at any point in the time. Okay, means it can only move to its right cell or it's the cell which is uh, down from the present cell. Okay, the robot is trying to reach the bottom right corner of the grid. So here, as you can see from the Android symbol, this is the starting point of the robot, and the star symbol, this is the finish point of the robot. That's the destination. The robot is trying to reach from the starting point to the destination, passing through all these cells. Now consider if some obstacles are added to the grids. Here it's an obstacle. See, there's the red color stones, these are the obstacles, okay? How many unique paths should be there? An obstacle and a space is marked as 0 and 1 respectively in the grid. Okay, fine. So it's in the previous problem we don't have any obstacle, but here the obstacle is also added. Okay. So we have to complete the function unique paths with obstacles, then put in the form of vector of vector. Okay. First, let's consider what is vector of vector. Okay, fine. So okay. Suppose vector is a container, means vector can contain anything, be it a string, a vector or an array. And vector of vector, and second of all, vector is a sort of dynamic array. Okay, means in an array, when you are defining an array, at that moment we have also to give the size of the array, but here we don't have to provide the size. So suppose this is an array of array, so it will be many arrays. This is the first array, this will be the second array. Okay, sorry, it is a freehand diagram, don't take it. And the third array can also have no size, it can be empty. The fourth array, it can be much bigger, and so on. Okay, so let's erase this. Okay, okay, so now here we have vector of vectors. So but here, since it is a grid, it is already told it's of m, it is an m cross n grid, so it will be of some this size. Okay, sorry. So this is n, this is m. So m will be the size of the grid, means the number of rows will be the size of the vector of vector, and the number of columns will be the size of the vector. Okay, to make more clearly, the grid is a vector of vector, means it is a combination of so many rows. Okay, and here we take a single vector as a row, and so this is So we have one row, two row, three row, four row. So the number of rows equal and the number of cells in each row is the number of column. Okay, so the number of rows equal to the size of the vector and and the number of columns is equal to size of the vector. Okay, after that we construct an array or means a table of n cross m size, and the table will be implemented using a two-dimensional array data structure. Okay, we'll initialize each cell of the array as a 0. After that, now let's start filling the table. Okay, so here you can say if the top left cell is an obstacle, there will be no way to reach it. Otherwise, there will be one way to. Otherwise, there will be only one way. Okay. So suppose this has an obstacle. So how can you start? Means the robot cannot even start. So it will not have any way to reach it. Otherwise, it will have one way to reach. Okay. So it's fine if the obstacle grid 0 0 equal to 0. Here it is already showed that 0 is a free cell, means it has a space and it don't have any obstacle. So if the starting cell is a free cell, means we can move out and go into it, then there will be one way to reach it, otherwise there will be 0 way. Okay. For the leftmost cells, if the cell is not an obstacle, the number of ways to reach there is equal to the number of ways to reach its nearest upper cell. If the cell is an obstacle, the number of ways to reach it is 0. Now suppose talking about this row, okay, the top row. As we know that the robot can only move either to its right or to its bottom. So we can reach this cell only by moving through this very cell. Okay. Again we can reach this cell only by moving through this very cell. But if here we approach an obstacle, we cannot move into this cell. So if we cannot move into this cell, we also cannot move into this cell. So number of edges here is 0 0. Similar is for this column also. Fine. Now let's start come to filling this inner side. Okay, suppose this is an obstacle. Okay, this is an obstacle. So coming to this, if you want to come to this cell, we'll have to, so this will be, there is one way to move into this cell. Okay, one more. So we'll move here or here. There will be two ways to move into this cell. So 2. Okay. After that, for coming to this, we'll have 3 way. But coming to this, when talking about this very cell, we cannot come from the upper cell because it has an obstacle. Okay. So there will be only one cell, one way. Okay. Now when we talking about this cell, it will have 3 way. We cannot move into this cell because it has an obstacle. Okay. Five ways, 4 ways, 9 ways, 3 ways, 7 ways, 16 ways. Here again we will encounter an obstacle from this side, so there is no way from this side. Again this will be 16. This will be, there will be 3 ways. There will be 6. again 3. Here this cells don't have an obstacle, but we cannot move to this cell because there is an obstacle in the right of it and there is no cell above it. Okay, so we cannot move to this vessel, so there is no way to reach this cell. So from this that we are not able to reach this very cells. How can we reach to another cell via this cells? Okay, so it has 9. Again here we cannot move from the right cell, so there is only tops way. So 96, how much? I don't know. 25. So finally there will 25 unique ways. This is the answer. Okay, now let's code it down. So the starting cell, if it is, I already told that if it has an obstacle, there is no way to reach it, otherwise there will be one way. Okay, now come to the filling of these columns and this column and this row, the topmost row and the leftmost column. Okay, so here we will fill the column. So if the obstacle grid equal to 0, if the column has a free cell, means it don't have an obstacle, the number of ways to reach it is exactly equal to the number of ways to reach the its upper cell. Okay, similarly the talking means the number of ways to reach this very cell is equal to the number of ways to reach this cell. Okay, similarly talking about this row, the number of ways to reach, suppose this cell is exactly equal to number of ways to reach this cell. We can take an example here also, because here as we have no way to reach this very cell, we are not able to reach these cells, so there is 0. Okay, now finally we will code the rest of the part, this part. Okay, so here we'll first move this way, then again this way. Okay, we have a nested loop which transverses through this 2D array. So if so we have already initialized the obstacle grid every cell with 0. So if it's an obstacle, there is no way to reach that, and finally it will be 0. So we'll just continue. Otherwise, it will be the some number of ways to reach its left cell and the upper cell. So this will fill the whole of the array, the 2D array. Means if I want to emphasize this, the number of ways to, suppose, let me clear this. Sorry. The number of ways to reach this cell is equal to the number of ways to reach its left cell and the top cell. The sum of the ways to reach the left cell and the top cell. So it will be 7. Okay. So in this way we will fill all of them, and finally here we will have the answer. So I have already written the code, I have already submitted it. It is a true code. So let's submit it. Oh my goodness. Okay, no problem. It's this I have already submitted, as you can see. By mistake I have sent it out. Okay, so we are done here. Thank you. If you enjoy this video, please like it, subscribe my channel, share with your friends, and thank you for your attention.